Fox, you wanna tell him all you know about GraphQL? He's kind of an expert, guys. Listen, I've been doing development for a while now, and specifically quite a bit of API development. I've done RESTful API development, I've done microservices, and I've done GraphQL. And I really believe that GraphQL APIs are the future of this industry. Listen, if you are planning on working in this industry for a long time and you're planning on working at cutting edge tech companies, learning GraphQL is a must in my book. I really do think that RESTful APIs will start to drown out in favor of GraphQL APIs. That poses an important question though, and it's the one that we're going to be using to get us started. It's what is GraphQL in the first place? And when you compare it to a more traditional paradigm like REST, where does it differentiate? Whenever we're adopting a new technology, I think it's really important to understand what problem that new technology is solving. People didn't swap off of Angular 1 just because they wanted to. They swapped off of Angular 1 to React because React offered a key set of benefits that made it a better framework for front-end work. And just the same, I believe the industry will move towards building GraphQL APIs, not just because GraphQL is the hot new thing, but because I really truly believe that GraphQL APIs are a better solution to the problem that REST was trying to solve. As a jumping off point, let's talk about what an API is if you're not sure. In a nutshell, all an API is basically an application that's sitting on some server that's meant to serve CRUD operations for other clients to consume. Now, if you're not initiated, what I just said might not make any sense. Let's talk about a more specific example. Let's talk about building a social media platform, something like Facebook. Facebook has posts. Those posts exist in a database. Now, users who create the posts need to be able to do a series of operations on the posts to interact with them. They need to be able to, like I just said, create a post. They need to be able to read posts or look at posts that they've posted and that their friends have posted. They need to be able to update their posts, so if they make a typo, they can change it. And for those situations where your aunt gets too political, she might need to delete a post. Those four operations are really the core of what most APIs are doing, and we typically call them CRUD operations. CRUD for create, read, update, and delete. Imagine we're Facebook again. We're building a mobile app, probably TV apps, web apps. We have these multiple platforms or clients for users to use. Now, all of those clients share the same data, right? If you go look at posts on your web Facebook, it's going to be the same ones you'll see on your mobile. The way Facebook achieves this is they have what's called an API layer, or essentially an application that's running on a server that's serving those posts to the different clients. Now, there is an option to just have one server that's serving what we call a server-side rendered application. And that's not necessarily important for this, but the reason that you typically don't do that out there for larger companies is that for each of those separate applications that you might build, you would have to have these separate servers. So what we typically do is we'll build one single API for all of our different clients to interface and work with. Now, there are no rules about how your API works, right? Typically, APIs work over HTTP or HTTPS, so you send some request to the server side, and then that request responds with some data after doing whatever operations it needs to do. At its core, there's no rules there. If I wanted to, I could make an endpoint called api.myexample.com/hugs, and what that API would do would be create a post. Now, that doesn't make any sense, right? So what developers have done is they've come up with a series of conventions, the most common of which is REST. The main idea of REST is that each of those four operations, create, read, update, and delete, are represented by the HTTP method that's used for the request. All HTTP methods are essentially additional little headers that are attached to the request, but the idea is that every single operation you do, whether it's a create, read, update, or delete, has a HTTP method attached to it that's descriptive of that operation. So for example, for read operations, you'll typically see get requests. For create operations, you'll typically see posts. For delete operations, you'll typically see delete, etc. Now, this paradigm is great. And it's not just great in one company, it has huge benefits that this paradigm spans across multiple, so that you can jump and integrate with all of these separate APIs, and they're using very similar REST paradigms, which makes it much easier to use other people's code. However, REST has its issues, and let's talk about a few of them. First, what happens when I need less information than the API is giving me? I'll give you an example. Let's look back at our post example when we were talking about building Facebook. Facebook's get posts endpoint might be responding with a large amount of information. They might be responding with the names of the people who made the post, how many likes it has, the number of comments, the content of the comments, etc. But if you're using that API to just build a place where you're just listing plain text posts and don't care much about any of the additional information, or maybe you're building a place where you're just trying to aggregate like totals to gauge engagement, then you're getting far too much data for what you actually need. Now let's imagine another example. You want to build an interface for looking at posts, and your requirement is you need to be able to see not just the number of likes, but the people who have liked that post. The problem is there's two separate endpoints here that you might have to hit. There's one for getting the posts, and then there's an additional one for getting the actual likes on the post. Not just the count, but the detailed description about who liked what. That's two calls. Wouldn't it be great if we could do it in one? Well, if you work at Facebook, maybe you could go develop that endpoint yourself. But oftentimes in these large companies, what happens is the team that develops an API is drastically different than the team that's working on the client side. And that can cause issues because the client side might need a very specific endpoint that's serving it very specific data so that it can create the application that fits its requirements. But in order to do that, they're blocked by this other API team needing to build a specific endpoint to meet those needs. Now, if you're that API team, you might be getting hundreds of requests for you to build this very specific endpoint, and it becomes difficult to prioritize what you should build. And this ends up where a lot of the times in a traditional REST company, either the clients will have to make their own separate services just for these custom one-off endpoints, or you'll have large amount of time being blocked, or the third option is you just work with the worst solution and your end users have to suffer. The main thing I want you to notice about REST APIs is that the onus for what the API is giving back is purely on the API itself. And the client is stuck with whatever the API is giving it, and it has to work with those constraints. And that's true for all different kinds of endpoints. So even creates, right? You're gonna run into a situation where you might do a create of some object and you want like nested fields back that exist on it, but you can't do it because the API might only give you back an ID, or it might only give you back the root level object that was created. You don't have that control on the client. The full onus is on the API. The biggest thing that GraphQL changes, and the reason I think it's so huge, is it inverses that onus. Now, no longer in a GraphQL API is the onus on the people creating the API. In a GraphQL API, the onus is on the client itself, and I'll show you how. So let's take a look at how GraphQL inverts that control from being on the API side in our typical REST API to being on the client side. So what we have here is a diagram of what a typical REST API might look like. So we have a client here, and that client is going to go ahead and it's going to make a request to our server side. This is our API right here. And just for continuing with the same example, we're going to be talking about posts, like we talked about that Facebook example earlier. Now, the API here is going to have a lot of different endpoints. It's going to have endpoints for posts. It's going to have endpoints for comments. It's going to have endpoints for users, right? But the API, this guy, is what defines what all of those endpoints are. And critically, it defines what it's going to be giving back. So what happens is the client, in this case, this computer, sends this request out for posts. And then what happens is the server, the API in this case, responds with the posts here. Okay, but critically, it's the API that decides what goes in this object here. The API is the one that decides what it's shooting back. So if you wanted to build a page that was showing a post along with its comments, you would likely have to hit multiple endpoints, because here what we're seeing is that this post endpoint, it's only giving us back the title and the content, right? We don't see any details here about comments. So, the client is going to have to go and make an additional request, or you're going to have to go to the API development team and have this changed. But then if it's changed, you run into this situation where maybe this post endpoint was also used by other teams, and now they're going to be getting more information than they need. It creates this big issue. So let's see how GraphQL changes that. So here's our GraphQL example. And you'll immediately notice a difference here, that we're sending this query from the client side. So whereas in this REST example before, we'll go back to it here real quick. In the REST example, we talked about the API having multiple endpoints. We've got /posts, but we would also have more endpoints like /comments, /users, etc. In a GraphQL API, instead of defining a series of endpoints, what we have instead is what we call a GraphQL schema. Essentially what that is you can think of it as very similar to a database schema, but it's a graph, hence GraphQL, of all of the different entities that exist in our system and how they relate to one another. So what that means is that now, instead of having to go to these separate endpoints, the API just says, okay, here's all of the things I have available. I have posts available, I have comments available, I have users available, and then it's on the client here. The client is the one that goes ahead and says, here, give me these specific things. The client is the one that's deciding that it wants the title and the content, not the API. The API says, I have all of these things available, and it's up for the client to pick and choose which things it wants. So in our case, we've included ID and number of likes that weren't in that REST API example, and we included them just because the API says I can get these things, and we can add things or omit things as we see fit on the client side. That level of control is what makes GraphQL really special. So what we see here is the API goes ahead and responds back. It gets the request coming in. Give me all of the posts. I want the ID, the title, the content, and the likes. And the API goes ahead and shoots out the JSON data back to the client. But what's critical here is that the client is the one who decides what it wants versus the API deciding what it's shooting out. The API says, here's all of the things I have available, and then the client decides what things on the graph does it want. Now back to this REST example, we talked about how much of a challenge it might be if we wanted to also get like the comments that exist on a post. And that can be a challenge in REST because we're going to have separate endpoints. We're going to have one for posts and then another one for comments. So we're going to have to go to these two separate places to get the information we want. And depending how things are structured, we might have to end up sending a lot more requests than just two. But watch this. Look at the beauty of GraphQL. In a GraphQL environment, all we need to do from the client side is include that we also want the comments in our query. And that's where the graph comes out in GraphQL, right? A graph is a data structure where we have these nodes that are connected through different connections. And in this example, we have a post that could have multiple comments inside of it. So the comments become nested within the post. Now, these comments exist on the schema as well, and we could query for them independently, but that graph power is really shown here, that we don't have to make these additional requests. We can construct the exact query that we want from the server side. That right there, the power for the client to construct a query that contains exactly what it wants, that is what's making GraphQL so huge in the industry. It allows API developers to give front-end developers the control. It allows them to create a single place, this one single GraphQL API, that can allow multiple clients and a wide variety of use cases without the clients having to compromise their own performance or having to ask the API developers to make these one-off endpoints. It's incredibly powerful. This is the first video in a series I'm going to be doing on GraphQL. If you enjoyed it, please consider subscribing so you get notified when other videos are released. In later videos, we're going to be diving deeper into exactly what a GraphQL schema is. We're going to be implementing our own. We're going to be talking about how to efficiently query it on the front end and use modern tools like Apollo Client and GraphQL codegen to make our code faster than even I thought was possible.